Welcome to this video. So today we start solving tutorial sheet 1, which is on trigonometry. Okay, which is on trigonometry basically. So we have about 9 questions in this tutorial sheet, and we're going to make sure that we solve each and every one. Okay, so you can see the first one is just on conversions from degrees to radians, and also radians to degrees. And then we have these questions where we have to evaluate such trig ratios without using a calculator. Okay, we have some sequences to prove on question 4, and then question 5, 6, and even 7. I think they focus on sketching these trigonometric functions. Okay, and then we also have some equations that we have to solve. Okay, trigonometric equations. They are very easy. We just have to take advantage of the use for identities. Okay, so all the way up to question 9, where we'll be proving identities like these ones here. Okay, so I hope you'll be there when we'll be proving all these. Okay, so otherwise, let's start from question 1, which is on conversions from radians to degrees and degrees to radians. All right, so the first question here, they're saying the list below shows angles, okay, which have been represented by theta in both degrees, okay, and radians, okay, or in both a degree measure and radian measure. So they're saying convert every degree angle to radians, and then also convert every radian angle to degrees. Okay, so it means that all these angles here that I'm putting in a box, they're in degrees. We're going to convert them to what? To radians. And then these ones that I've not put in a box, they're in radians. We're going to convert them to what? To degrees. Okay, so here we just use a very simple formula. Okay, so to convert from degrees to the radians, okay, we're going to use the formula. Radian is equals to pi over 180 degrees times the angle that you've been given in degrees. So the D means degrees, the R radians. Okay, so that's what we are going to be using when we are converting from degrees to radians. Okay, so let's start with the 120 degrees. So we're going to say the 120 degrees in radians is the same as pi over 180 degrees times, okay, the angle, which is 120 degrees. And then from here, I can multiply. So I have 120 degrees pi over 180 degrees. So here, okay, the 2 degrees will cancel out, okay, and then this 0 will also cancel out. So I remain with 12 over 18. Okay, I remain with 12 pi over 18. So now we look for a number that can go into 12 and 18 without leaving a remainder. So that number is 6. So 6 into 12, it will give me 2 pi over, and then 6 into 18, it will give me 3. Okay, and these will be in radian measure. Okay, so 120 degrees is the same as 2 pi over 3 in radians. Okay, what about 285? So we're going to say that angle in radians is equals to pi over 180 times, okay, 285. So this will have 285 pi, okay, 285 pi over 180. So here, we just have to look for numbers, okay, that can go both into 180 and 285. Okay, we look for numbers that can go into 180 and 245. So let's try 15. Okay, let's try 15. So 15 into 285, okay, I'm getting 19 pi. And then 15 into 180, what am I going to get? So 180 divided by 15. Okay, I'm getting 12. Okay, so right. So this means that 285 degrees, okay, it's the same as 19 pi over 12 rad. Okay, let's convert the 320 and the 720. So the 330 to be pi over 180 times 330. Okay, so this becomes 330 pi over 180. So we can cancel out this 0 and this 0. Okay, so I remain with 33 pi over 180. So I see that I can divide both by 3. So 3 into 33 is giving me 11 pi over 3 into 18, it's 6 rad. So this 330 degrees is the same as 11 pi over what? Over 6. Okay, so we are just left with this one. So this one to be rad is equals to pi over 180 times 720. So the 0 and the 0 may cancel. And then we can say, let's try to divide both of these by 9. Okay, so because I have 72 pi over 18. Okay, so if I divide 72 by 9, I get 8 pi over. If I divide 18 by 9, I get 2. And then this will be the same as the 4 pi. So this is very easy, right? So another way you can solve this, if you do not want to use the formula directly, or in case you forget the formula, always remember that pi is equals to 180. Or in short, okay, pi rad is equals to 180 degrees. Or in short, we can say 2 pi rad is the same as 360 degrees. So in case you forget this formula, always remember this, and then you can use a ratio to convert. So for example, this 720, I can say my 2 pi is 360. What about x, which is equal to 720? So this will be cross multiply. I'll have this multiplied by that. So it will be 360x is equals to 720 times 2. And then I'm going to divide both sides by 360. So 720 by 2 multiplied by 360. I'm going to get 4. Okay. So I forgot the pi here. So there's a pi from the 2 even there. So when I divide there, I'm going to get 4 pi, which is the same one that we got there. Okay, so if you don't want to use the formulas, just remember this relationship here. All right, so we are done converting degrees to radians. Let's now do the opposite. Okay, so now what we are doing is that we are converting from radians to what? To degrees. Okay, so here there's also a formula that you can use. You can say the angle in degrees is equals to 180 degrees over pi times the angle in radians that you've been given. Okay, so let's start with 5 over pi over 5. So I'm going to say the pi over 5 in degrees is actually, okay, 180 over pi multiplied by pi over 5. So this will just be, you can see that this pi and this pi will cancel. So it will be 180 divided by 5. Okay, so 180 divide 5, I'm going to get 36 degrees. Okay, so pi over 5 is the same as 36 degrees. Okay, what about 3 pi over 2? So this is 270, but let's show it. So angle in degrees is just going to be 180 pi multiplied by 3 pi over 2. So as usual, the pi will always be cancelling. Okay, so I remain with it 180 times 3 divided by 2. And then I can cancel these 2, 1, 2 into 180, it's 90. So 90 times 3 gives me my 270 that I mentioned earlier. Okay, so it's the same thing. So let's convert this, and then I can leave this one for your exercise. So when you convert this, make sure to inbox me so that I can guide you if you've gone wrong. Okay, so let's convert that 25 pi over 12 to degrees. Okay. Okay, this is nice. Okay, so we're going to say degrees is equals to 180 over pi times 25 pi over 12. So as usual, while pi will cancel out. So this pi cancels out with this. But now, let's try to divide let's try to divide 180 by 12. So if I say 12 into 12, it's 1. 12 into 180 is going to give me 15. So what I have is 15 times 25. Okay, so 15 times 25 is giving me 375 degrees. Okay, so that's basically how you can easily convert from radians to degrees and from degrees to radians. Okay, so thank you so much for watching this video. If you'd like to access the full video solutions to all the questions that you're seeing in this tutorial sheet, okay, be free to register with us. Okay, so you can access the full video solutions on our website. Okay, our website is discretelearning.com. Okay, so discretelearning.com. So you can search it on Google. Okay, once you find it, it will tell you to create an account there. If you already have an account, just log in. Once you create an account, you can register for this course, okay, which is math. And then you'll be able to access the full videos to all these questions that you're seeing here, plus even the other tutorial sheets that you're going to have, plus past papers, mid-semester exams, and final exams as well. Okay, so you get to learn easily, fast, anytime, at your own pace, in your own blankets. Okay, no need to move. We are learning smart. All right, so thank you so much. And you can reach me on this line. Okay, if you want to talk to me, you can reach me on the following line. Okay, so you can reach me on 763 99 34 77. Okay, so you can WhatsApp me and then I'll be able to reply if you need help in anything. All right.